You cannot see it, but the entire class is doing the wave. All right. Because they're so happy it's the last one. Not the last wave, the last section. The revenue for a parking meter grows exponentially with a steady rate of $5,000 per year. Find the total income over the first 10 years of the meter. Meaning how much did that meter make? And hopefully over that 10-year period, someone was hired to empty out that parking meter. Otherwise, it'll get full. Okay. So notice what they didn't give us is the function. We have to find the function. If only we had a friendly formula, I don't know, like a continuous compounding function that would give us the formula. Hey, look, there is a continuous compounding function formula there. So we have to use A equals PE to the RT. Notice we know how much we started with. How much did we start with? 5,000. We know how long it took to grow to 5250. But what don't we know? The rate of growth. So we ended with 5250. We started with 5,000. And it took 2 years to get there. So how do we solve for R? Divide by 5,000. Who remembers chapter 10? If you want 5250 or 5,000 does reduce, did you get a new fraction?
Oh, fraction.
Well, is it a nice decimal?
1.05.
Okay. 1.05. That is a nice decimal. I would take that home to mother. Okay. How do you solve for R? Yep. Natural log of 1.05 equals natural log of e to the 2r. So what happens to the natural log and the e? They cancel and you get 2r. Nice karate move back there. Very good. So what's r? Natural log of 1.05 divided by 2. Now, do you want me to be nice or be typical Mike? Fine. So if you would, we'll be nice. Please round that to 4 decimal places. Natural log of 1.05 over 2. No, would be keeping it just like that, because that's the correct answer. And we like perfection. We're sort of like the Greeks, except we don't get slaughtered by the Romans later on. And we don't wear togas. We're nothing like the Greeks, is basically what I'm trying to tell you. 0.0244. So in other words, this is a 2.44% rate of growth. That's basically what we just found. Okay. So our function in our total money flow formula there would be 5,000 e to the 0.0244. Well, I'm going to use x here because I call it f of x. X. Okay, now I'm better. Yay, so we found our function. So according to the total money flow formula, this is the rate at which we're earning money. So to get how much total money we have, we'll integrate. And we want this over the first 10 years, so we're going to integrate from what to what? 0 to 10. That should be an X, not a T. I got ahead of myself there. Sorry about that. There we go. Fantastic. What happens to the 5,000? Sure, it goes on the outside. Let's integrate this guy. So notice this has a special format of e to the k x dx. What is the shortcut for e to the kx dx? So if you have a number in front of your variable there. No. 15.1 notes. 15.1 notes. 15.1 notes. Yep. Now the plus c won't affect us here because we're doing a definite integral. I wonder if this will be helpful in a worksheet, namely a 12 worksheets. Cough, cough, it will be, yes, cough. What's our k here? Yeah. So we're going to have 1 over 0.0244 e to the 0.0244 x with the bounds from 0 to 10. Now we're going to throw this all into the calculator in a second. So if you want to, but I wouldn't recommend it, you can clean up 5,000 divided by 0.0244. But it's going to go in the calculator. Please note, when you stick in 0, you do not get 0. Because it's not a polynomial. So again, stick in 10, subtract, stick in 0. So now we have a number. Let's talk about this. So we know we started with 5,000 per year, and it's growing by a little bit, 2.44% each year, right? So as base minimum, if it weren't even growing, 5,000 per year for 10 years, that'd be $50,000, correct? So we should assume our answer is bigger than $50,000. So that's a small way of checking your answer to make sure it makes sense. So did you get a number that's bigger than $50,000?
Yeah.
What'd you get?
6,627.
Point.
0.9. How many decimals?
Well, it's money. Let's go 2.
0.94.
Yep. $56,627.94 for those of you at home. Congratulations. So again, this is basically revenue. The amount of money that was brought in, assuming that the money was brought in at a continuous rate. Which again, it wasn't, because there are gaps in between when money is put into a parking meter. But it's good enough.